All right, let's do this. Let's go right to the first problem here today. All right, let's take a look here. 18x to the third plus 9x squared plus 2x plus 1. First thing I want to discuss is what's wrong with all the other methods we went over yesterday. This is the first one you guys, I know it may not say example 2, but it's the first one you guys have in your packet, correct? I'm at the right spot. Okay, so let's talk. Why what we did yesterday won't work? Where's the first spot I always told you? Look for a what first yesterday? GCF. Go ahead. 18, 9, 2, and 1. You got one? Me neither. How many terms are there? That's a problem. No GCF and 4 terms. No GCF, 4 terms. We don't have a method until right now. Grouping. Does that sound familiar? All right. Grouping method. Automatic, no GCF, 4 terms. I want to try to group this. So let me go very, very slow on how I'm going to group this. First thing, I'm going to group these into 2 pairs. Usually we'll come across some that break this rule, but 99% of the time, we group the first 2 together, and we group the final pair together. Okay, we group them. Next, you take a GCF out of the first one. So 18x to the third plus 9x squared. The biggest GCF I can take out of that. Let's start us off right. 4. Great job. Good start. I'm going to take out a 9x squared from the first grouping. Just like we did yesterday. What's left now? If I take a 9x squared from that, what's left in that first parenthesis? Divide everything by 9x squared. What's left? Oh, 11?
2x plus 1.
Good job. 2x, and I love that he put plus 1 at the end and didn't close it. All good. All right, so we took a GCF out of the first pair. Now take a GCF out of the second pair, and I know some of you are going to stare at that and be like, what's he asking me about here? True, there is a number that you're used to that you can't take out, but you can always take out a what? Which you will take out here. Here's why. When you take out a 1, what's left over? Same thing. That's still in there, right? A 2x plus 1. And this is how you know you've done grouping correctly. What's left over inside the parentheses has to match. If it doesn't, you couldn't group it. You can't group it. Okay? What's left over in the parentheses has to be the exact same for you to group. So now we know, yeah, we could have grouped this thing. So let's keep grouping. You got a left and you got a right side. What's in common in both? What's the exact same in both sides? 2x plus 1. Take it out like it's a GCF. I'm going to take out 2x plus 1 because it's common on both sides. And after I divide everything by 2x plus 1 in the next parenthesis, what the heck's left over? Ready? I divided 2x plus 1 on the left side. What's still left there? 9x squared. I divide 2x plus 1 on the right side. What's left? Plus 1. Congratulate. Actually, wait, maybe. Wait. Hold on. Are we done? Here's why I'm asking. Here's why I'm asking you guys. 9, perfect square. X squared, perfect square. 1, perfect square. Can I keep factoring this like I did yesterday? Perfect squares?
Yeah. No.
What's in the middle? What's it gotta be?
Minus.
Come on now! You're better than that. All right? I trained you better than that yesterday. You're savages. That's got to be a minus sign. Got it? You can't. Ready? What's the method called? The what of perfect squares? Difference, meaning subtractions. You're not touching that. We're done. Congratulations. You just did your first grouping problem. Huh? Oh, boy. Gets me fired up. Next one. Why are you putting parentheses around first? Where do we live? First step, every factoring problem. Stay in your lane. Stay in your lane. Look for a GCF every single problem, factoring problem first. Is there one? Then take it out. Take it out. What is the GCF here I could take out? Oh, 12. 5, yep. Take out a 5 first. You got to look for a GCF every problem first. X cubed plus 2x squared plus 10x. What am I doing here? Get my act together. Plus 4x plus 8. That looks a little better. How many terms inside the parenthesis? 4. Probably going to group now, right? Don't stop. Probably going to group. And again, 99% of the time, we group the first pair and the last pair. Don't forget about the 5 in your answer. I'm going to forget about it now, but I'll remember it at the end, put it in my answer. Okay, what do you want to take out of the first pair? 17. What do you want to take out of the first pair?
I took x plus 2 out. Or, no, x squared.
Darn right you did.
Yeah. I got x plus 2.
And then you got x plus 2 in the parenthesis. Good. Yeah. Now look, hey, you better tell me x plus 2 in the parenthesis next. So take out the correct number here, so you're left with an x plus 2. Not x minus 2. X plus 2's got to be left. What do you want to take out? 11 of that second grouping.
4.
Because that's the only thing I could take out to be left with x plus 2. Parentheses. If the parentheses don't match, you either did something, you took out the wrong number, or you just can't group it. All right. For us, in this case, you probably took out the wrong number. All right, finish grouping. You're not done. Finish grouping. Here we go. 2. What's the same on both sides here I can take out? Look at the left and the right. What's x plus 2? Done. I take out an x plus 2. Divide each side by x plus 2. What's left over for the last parenthesis? 9.
X squared plus 4.
Great work. Again, don't forget about my 5. Keep going, or are we done?
No, you're done.
Thank you. Why?
Difference is it's a plus.
Darn it, it's a plus sign. If it was a minus sign, yeah, keep grinding. But we are done. Whew. How you feeling there, huh? We all right? Grouping? Group them. And then again, what's in that parentheses has to match for us to group. All good. All right, let me test your knowledge now. A little bit different problem. This student tried grouping, but he or she made a mistake. What was the mistake? Okay, so let's take a look. Let's go step by step, see if we can find the mistake. So they grouped, there's no GCF, so they said 4 terms I'm going to group. So it looks like first pair, second pair, right? They took a 2x squared out, which we should have. X plus 5, good. Should they have taken a 7 out of the second grouping? What would you have taken out? What would you have taken out here? A 7, right? And been left with x plus 3. So this right here, this first line doesn't look bad. They just grouped them, took a GCF out, and wrote what was left. Here's the problem. Coming up. What have we been telling you the last 2 problems about grouping? When can you only group? There's your issue, right? Everyone see it? You can't group this because these have to match. They tried to force it and try to look pretty, but they're just being an embarrassment by trying to combine them. Everyone see what I mean now? I think this really sets it in stone that whatever's in the parenthesis has to match. All right, so terms do not match. All right. How do you feel about grouping? Good talk. That's what I feel too. Here's the next, you guys can factor now. Here's the second type of problem I need you to do today. This is called an identity, meaning the left side and the right side, this is true, are equal to each other. You need to prove to me why it's true. In a nutshell, here's what we're going to do as a group. We're going to pick one side, the left or the right, to work on. And eventually, as we're working and working, it will match the other side. So we work on one side, don't touch the other. And as we're working on that one side, eventually it looks the exact same as the other side. Okay? We have to get one side to look exactly like the other side. So we need to make a decision. Let's make a smart decision here. What side do you think we want to work on? The left or the right side of the equal sign do we want to work on? Based on everything we've done so far today. Left side. All right? Because if we tried to work on the right side, we'd be doing all that foiling, double distributing, it'd take forever. But we can work on the left side. So here's how we start these prove problems. See where the equal sign is? Draw a nice little vertical bar down. Which side are we working on? We decided on what side? Then don't even sniff the right. Don't even write anything on the right side. All right, you want to work on the left. Any GCF? Nope. How many terms? 4. That means what? We can group. Correct. That's why we picked the left, I hope, right? Because we're grouping it. So hopefully, now listen, hopefully after we group and group and group, it's going to look like this. This is what we want. No other version other than this right here. No other version. I need this on the left side now. First move. Here you go. What do you want to take out of the first grouping? Oh, 10. What do you want to take out of that first grouping?
X squared.
Yeah, good job. And what's left?
3 plus 2. 3x plus 2.
Yeah, watch your mouth. Yep. So we better be left with a 3x plus 2 now. So take the right number out. Take the right number out. So it's left with 3x plus 2. What do you want to take out next? The GCF for this one. Got to be left with a 3x plus 2. 16?
9.
Yeah. 9?
-9.
Well, I don't know. Which one? Ready? Okay, let's say I go with your first answer, 9. Ready? Negative 27 divided by 9.
-3.
But what did I need?
+3.
So now what's your answer?
-9.
Darn right. See how we can check that pretty easily? All right, just divide, and do I get the same thing right away? Nope. So let me flip the sign. -9, 3x plus 2. Keep grouping. Keep going. Come on. Keep going. You're not done that. Not done grouping. 11. What do you want to take out from both sides here that are the same?
3x plus 2.
Good. What's left?
X squared -9.
Good. All right. We're done grouping. But look at the right side, though. Do they match yet? Do my two sides match? Hey, this is what's so great about these problems. You see that they don't match, you have to go another step. You know that now. There's another step to the left side because, darn it, it doesn't equal the right side. It's got to match exactly. And the only thing I have is 3x plus 2. So where the heck do these come from? X plus 3, x minus 3. Come on, dig deep from yesterday. 4. What else can I do here to possibly get an x plus 3 and an x minus 3? Darn right. X squared minus. Oh, now I have a minus. Now I have a minus. So now we can go 3x plus 2 and go difference of 2 perfect squares. Plus 3, minus 3. Awesome. But I'm a stickler for detail, if you haven't noticed already. Now what we do is to finish this off. Hey, look. They actually do equal each other now. So all you do is now bring all that right side down and say, hey, they are equal to each other. And you can even put a nice big check. You got it, boss. They do equal each other. So on these prove ones, don't touch one side. Work on one side till it matches the other one. Any issues? And I'm going to be blowing some minds here on the next one. Same type of question. Algebraically prove one side equals the other. And I know this looks intimidating. You can handle it, though. You can handle it. You don't have this here. That's not in there right now. All right. Prove that these two are actually equal. So now we got to decide. Let's draw our vertical line down. I got to make one side match the other. What side do you want to work on? I know you probably don't want to work on either side, but we do have to make a choice. Left side. Okay, here we go. Any GCF? Any GCF on the left side of the equal sign? Now that 6 is kind of hurting us. How many terms are there? 6. So you're probably like, we can't do anything to this because I don't know what to do. All right. Let's increase our definition of when to group. Usually it was no GCF and how many terms? Okay, let's increase that. No GCF, even amount of terms. Even amount of terms you can group. So how am I going to group this? Not once, not twice. 3 groups here. 3 groups, all right? 3 groups that look like this. So just because there's 6, ready? 1, middle, last 2. All right? As long as there's an even amount here, we can group them. And honestly, I'm not going to go above 6 terms, all right? It's either going to be 4 or 6. I'm not going to go anything more. All right, still follow your rules. What do you want to take out of the first grouping? X to the 4th minus x squared. What do you want to take out? 2?
X squared.
Darn right you will. What are you left with?
X squared minus 1.
Nice job putting the 1 in there. Everyone's good there? All right, second. Now, hey. You better tell me you're left with an x squared minus 1 through the rest of it now. Okay, that's the only way I can group it. Everything's got to be the same in the parentheses. So what do you want to take out next? 6? 5x. Yep, I'm going to be left with x squared minus 1. And again, last grouping, better be left with an x squared minus 1. What do you want to take out? 6 again, doubles. I don't know which one.
-6.
Thank you. Yep. Hey, a real quick check, right? If I take -6 divided by -6, yep, I get a positive 1. So I know I took out the right one. There it is. Good start so far. Any issues? I'm going to take a little slower now. Any issues? All right. I don't care that there's 3 groupings instead of 2. Rules still the same. 14. What's the same in all 3 here?
Yeah, x squared minus 1.
Take it out.
So then x
Relax.
1.
Relax. All right. Stop trying to drop all this knowledge. All right. We're good. Oh, boy. That comes back on me, huh? What do you want to, from the first one, what's left over?
X squared.
Karma, Carlina. Yep.
That's 5x.
Now look, notice how I'm putting it all in the same parenthesis.
-6.
Thank you.
I had a superstition I was going to be called again.
Are you done?
Yeah.
Okay. That's what I thought. What, too harsh first day? Too harsh? Second day of school? Do it saying that? Sorry. Don't steal my soul, please. Is that too harsh? Got the ginger joke out there? Too harsh?
A little bit.
Sorry, second day. Sorry, stealing souls. It's all right. It's all right. Hope you guys have tough skin in here. It's going to get brutal. You think that's bad? It's going to get brutal in here. So hopefully you guys have some thick skin. All right, you can take a joke. And I can take them too, so don't worry. We all good so far? Does that look anything like the right side? So guess what? We got to keep going. All right, we got to keep going because that doesn't clearly look like the right, not even close. There's nothing in common there. So anything I can do to either parenthesis right now. A lot of people struggled with this last period. Nick, what do you got?
The right parentheses are trinomial, so you can factor it.
Oh, wow, you went with the big one right away, huh? Remember yesterday? 3 terms. A value is 1. 2 numbers that do what? Multiply to? -6 and add to 5. Think about it. And I want to give you a little tip if you're struggling with it. You can cheat. You can cheat here. What do I mean by you can cheat?
You can look at the other side.
Look at the other side. You got an x plus 6 in there. So one of them's got to be x plus 6, right? You can cheat. Take a peek over. That's fine. So what's this going to factor into? Two numbers that multiply to negative 6 and add to 5. 8. Not here. Okay, that's all you're going to tell me. Not here. Thank you. 14. Oh, here we go. Threes.
I'm not sure.
Yes, you do. Two numbers that multiply to what?
Oh.
Negative 6, right?
Negative 6.
And add to 5.
So it would be negative. Let me do it.
And now, hey, look on the right side. That should give you a little push, right?
Yes.
Don't be telling me 3 and 2.
6 and 1. 6 and 1.
Yeah, darn right. Don't be telling me 3 and 2 because I don't even see a 3 and 2 on the right. You're still off the hook. I need the signage here.
And then that would be plus, and then both plus. And then 1 would be plus as well.
But that would add to 7.
Oh, negative. My bad.
Okay, you'll see where that plus 1 comes in a second. Everyone good so far? All right, that still doesn't look anything like the... I'll still leave it. I'll just write this. You guys can do what you need to do there right away. But all right, what can I still do with the x squared minus 1? 8.
Not here.
I'll remember that. I'll remember it. That'll be the last time. This is exactly how the generator works sometimes. X squared minus 1. What do you know about x squared? What do you know about 1?
That could take the.
That could be
X, yeah, that could be.
that could have been a 25, a 36, a 16 instead of a 1. All examples of perfect.
Squares.
Okay, so how can you factor this one?
You could put X, and then you would do minus 1.
Yeah.
And then plus 1.
There you go. Now, doesn't it look exactly like my right side? Anybody want to help me? How do I get this? Where's this coming from? X minus 1 all squared. Where's that coming from? Go ahead, Jay.
Because there's 2x minus 1.
Correct. And that the 2x minus 1s here become x minus 1 squared. Whoo, boy. Really put you to the fire here. That was a tough one. I'm not shying away from tough problems here. Not shying away. You can handle it. That's why you were put here. Anything? I'm going to give you a little breather here. Okay, that was a tough one. I'll give you a little breather. Oh, don't want to show that. All right, take a breather. Everyone have a good first day yesterday. Good to hear. Great, great. First 2 days not going bad in here.
How was your first day, Mr. Carlino?
It was busy. It was busy trying to get back into teaching shape, you know? Busy. All right, you ready?
Yeah.
Good, thanks. We're still factoring, but we're going to, as some of you may have already figured out, we're running into a problem on this one. How many terms?
3.
Yep. Any GCF? GCF? Nope. What's the number out in front, the A value?
6.
6. So I can't go, hey, somebody give me two numbers that multiply to negative 5 and add to negative 13. That's not going to work because that's a 6 and it should be a 1 to do that. So, okay, group? No, because how many terms are there?
3.
Yeah, you're correct. So we're stuck. We're going to use a little magic now, though. We are going to group. We are. That sounds crazy because how many terms do you need to group? An even amount, at least 4, right? We're going to turn that 3 into 4 right now. We're going to turn 3 terms into 4. You ready? First step, you multiply your A and your C value together. What's my A value?
6.
What's my C value?
5.
-5. Making sure the sign goes with it. What do we end up with? Okay, -30. There's your first step. How am I going to make 3 into 4? Ready? I'm going to take the middle term, which is what?
-13.
-13x, and I am going to break it into 2 different terms and leave the C value the same. So that's how I make 3 into 4. I'm going to take the middle and break it up into 2 terms. How? We've played this game before. In your mind right now, think of 2 numbers that multiply to the -30 you got, but at the same time are going to give me what in the middle? -13. So start grinding away right now in your head or your calculator. Can you write down 2 numbers in these blanks that multiply to -30 but add to -13? This is a tough one. I gave you right off the bat with those numbers. Two numbers that are going to multiply to -30 but add to -13 there. Break that -13 up. It's tough. You think you have it, but that might not be the right pair. See if we got anything. Ooh, 13?
-3 and +10.
Add those 2 up. What do you get? Right? Okay. There's got to be more out there. This is what everyone focuses on, these 2. There's another pair out there, though, that give you 30 and can give you 13. Dig deep. Dig deep. 5 and... Oh, you got me there. That does. Can you make a 13 out of that? Okay, keep going. You got it. You got it. So come on, dig deep.
15.
Okay. Not off the hook yet. How do I make that a -13? Negative. And there you go. Hey guys, look. Combine these right now. Don't you get -13? This is the same exact thing as up there. Same exact thing. We didn't touch a thing. Also, hey, quick comment. I could have flipped these 2. That could have been 2x and -15x. It won't matter. Okay, that order doesn't matter. Now, how many terms do we have?
4.
Now we can do what? Group, yes. I thought there would be more excitement there, but now we can group. Yes. Okay, what are we taking out of the first one? Who we got up? 17. Deep, going deep.
I took 3x,
Darn right you did. And what are you left with?
x minus 5.
Good job. X minus 5?
Yeah.
6 divided by 3, right? Make sure you're dividing.
2x.
2x minus 5, yep. So make sure I'm left with the 2x minus 5 next. What's the only thing I can take out then? 16. A 1. Finish grouping. Finish. That's not finished yet. That is not finished. 5. Finish it. Great job. Yep. And then what's left over for the other parenthesis?
3x + 1.
Perfect. Awesome. So I'm going to make 3 into 4 by taking that middle term and breaking it up into 2. Issues before we get to the beast.